Okay, great. So 7:30, we'll get started. This is our second workshop of the semester. We are going to talk about or work on some practice questions relating to linear algebra. So just points, not intersections. We'll deal with intersections next week. This week is points and slopes and just equations of lines and some related lines, but not quite intersections yet. I've put a full list of the questions. They're on the Google Classroom pages, also on the event details on my SoulBridge, so you can see all of that here. This whole list of questions. I hope you had a chance to look through these or try some of them, like maybe the ones that you thought might be a bit trickier for you. That will definitely make this process here smoother. I made two small changes, 143, that's a different one instead of 141, and then 195 instead of 197, just to give a little more variety. Some small changes there, but the rest were the same, or that's the same list here. Just in case you're not in the Math for Business class now, it's this textbook. This is the name, Intermediate Algebra, 2nd edition. It's at that website. Just search OpenStax and then just click through some links and find this book. It's not very hard to find. Free open source textbook. You can just download the book. There's a link right there. All right, we'll just go through a bunch of examples. I need my timer here so I know how long we're spending on each question. Last time, and I think often in class, I sort of give a fair bit of work time. I sort of plan to not do quite as much work time this time. Again, I've posted the questions in advance. Also, I don't think any of these are quite so hard. Rather than give you a whole bunch of work time, if maybe these are confusing for you and you don't know how to do them, I think it's a little more useful if I'm able to spend a bit more time explaining instead the questions. So we have a big list here. That's what, 6 and 6, 12, 15. It's about 20 questions. So we'll see if we can get through them all. That's 6 minutes per question. That should be all right. We'll see how the pace goes. We might take just a short break halfway through. Probably take most of the 2 hours here. All right. I hope you have some paper nearby and ready to use. A few of these questions involve graphing as well. So if you have some graph paper or some kind of grid paper you could use, that will be useful as well. All right, perfect timing. I think I have an eyelash in my eye right when I want to start here. Okay, I think we're all right. All right, first one. We looked at this in class either yesterday or today, depending on which section you're in. We have a line, an equation here, and we want to know if the points that are given are satisfy that equation, if they are on the line represented by that equation there. So I'll give you a moment. Let's just take, I don't know, 30 seconds, 40 seconds right now. Let's try them out. See, and for each one of them, if you think yes or no. All right. Yeah, maybe 30 seconds wasn't quite enough time. That was 1 minute. So can someone just remind us, what is the process? If I want to know if point A lies on this line, what can I do?
Substitute the numbers.
All right, so for A, each of these points, it's X comma Y. These are all XY pairs. We have an X here, we have a Y here. So just substitute in the numbers and see if it works out. So for the first one, point A, we get -3 is equal to 1/2 times 0 minus 3. -3 equals -3. Both sides are equal. How do we interpret that result? Does it mean it is on the line or it isn't on the line?
Change it to the other side with a different signal.
Nope, we don't have to move everything. This is the final form. We just have to interpret. What does this mean?
When is on the line.
Yes, it is on the line because the two sides are equal. If it was not equal, it wouldn't be on the line, but the two sides are equal. So yes, we got a check mark here. A is check mark on the line. Next one, B, we do the same thing. I guess we don't have to go through all of these. I'll do B and then skip to D here. So for B, we have -2 is equal to 1/2 times 2. That's the X minus 3. And simplify, -2 is equal to 1 minus 3. -2 equals -2. Both sides are equal and it works out. So B also is on our line. Let's take a look at D just for some variety here. Point D. So once again, the same equation. So we have 1 for the Y value equals 1/2 times 4 minus 3. So 1 is equal to 2 minus 3, and we get 1 is equal to -1. How do we interpret this result?
It's not following
the line.
Okay, so it's not on the line. D does not work because the two sides are not equal. As I wrote in class, this is what we call a contradiction. So we assume that it is on the line when we do the substituting step, but then when we simplify, we get this impossible result. So that's a contradiction and D is not on the line. C also is, it's the same process as the other one. So I'll leave that one, but C is also on the line. D is the only one that is not. Okay, so that's how we check. I don't know if you guys can hear that. Just not too far outside this window, there's a child, like a young kid baby who's like just screaming and screaming. They've been going on for about 20 minutes. I don't know if
it's okay for we don't hear any.
You don't
sound.
hear? No. Okay. All right. Maybe if the baby gets louder. All right. Okay. And this is the actual graph here. So if we use this, we could confirm all of these points. Let's switch colors. So point A, 0, -3, that's right here. So yes, it's on the line. 2, or point B, 2, -2, that's right here. Yes, on the line. C is -2, -4. Yes, it's on the line. D is 4, +1. That is not on the line. for -1 would be, but for +1 is not. So if we have the graph, yes, it's very easy to check this, but we should also know how to check it using algebra, doing exactly what we did here. Algebra is more precise. Okay, moving on. Next question, 21 and 27 here, just graphing these lines. The one on the left, we can use a table of values. The ones on the right, we don't need the table. There's special cases, so we shouldn't need that. Okay, table of values, what does that look like? What do we do to make a table of values for this equation?
Can I answer?
Sure.
Good evening.
Good
For a table of values, and we give values to x and y. For example, once we give 0 for x, and we calculate the value of y when x equals 0.
Okay.
For example,
so
here, if equal 1. Yes.
it would be 1
Like this.
because we would substitute in a 0 here for the x. We don't even need to like write this out. We can just see, okay, the x whole thing here would disappear. It would just be 1. What other values do we want to use in our table of values?
1 or -1, maybe 2 or -2.
Those will work, but if we look at the slope here, if I look at this fraction, I think there are easier numbers that we could use. There's no reason to make it harder for ourselves.
2 or 5, -2 and 5, right?
Which one?
And
one?
rise is -2 and
No,
run is 5,
I'm,
right?
I'm not asking what is the slope. I'm asking what value of x would be easier to evaluate here.
5.
Why 5?
Because
5.
when we multiply 2 over then 5 for 5 will disappear.
Okay, so the 5 on the bottom of the fraction will disappear. Y is equal to -2 plus 1 right here. So y is equal to -1. So that's much easier. So if you're doing a table of values, you don't need to do 1, 2, 3, -1, -2, -3. You can just choose values that make your job easier. So in this case, 5 gives us -1, and that's much easier. So another easy value like 10 or -5. What would the y value be if we substitute in 10 here? $10 and -5. Tell me what those two would be.
1.
Not 1.
-3.
Okay, for
3.
which value?
For 10, I think it's -3.
Okay, and for -5?
It's 3.
Well,
This one is +3. And from here, this is enough. We can see the pattern. If we did -10, then we can be pretty sure this would be 5. So it's just changing by 2 each time. Someone said we had a 1 here, but then someone said that this one would be 1. With a straight line, that will never happen. Straight lines, you will never get a repeated y value like that. So for different x values, that's a unique mapping to y values for straight lines. Non-linear situations, that's different. But for linear situations, if you get the same y value twice for different x values, you have a problem. Okay. So there is a table of values and we could graph that. So let's hop over to our graph here. Yeah, it's a little hard to read with the background, but it's still mostly okay. All right, so if we were to graph this, we just choose or we don't choose values, we have them already. So each of these are points on our graph. So that's a point, that's a point, that's a point. The ones with the x values of 10, actually, no, we'll be able to see those as well. They'll be on our graph. So 0, 1, that's this point right here. 5, -1, that's this point right here. 10, -3 is this point right here. Okay, that's 3 points. That should be enough. We will connect them. I have to work in the other order because my Zoom controls are hiding part of the screen. So let's do here. Okay, so I draw a line that connects these three. All three lie on the line. So not just two of them, but all three. So I'm pretty sure I have the right number there. So I want to double check 5 and +3 here. And also 10, sorry, -5 and +3 and -10, +5. So all of the points that we calculated are on the line. We can be very certain we have the correct line here. All right, 27, the other one. So two special cases. First one, we have an equation where just x is equal to -2. Already, before we even graph it, we should know a lot about what this looks like. So what do we already know about that?
It's a vertical axis.
Okay, so this is a perfectly vertical line going, and where will that line be?
From -2, it will be a perfect.
Okay.
Right, vertical.
So from -2, so a perfectly vertical line going through the point where x is equal to -2. And it would just go like this. I'll shade it in a bit to make it easier to see. So that's it. So special case, if it's just x equals something, that means it's a vertical line. So the x values are always -2. The y values can be anything else. Other one here. So the green one, y equals to -5. What should that look like?
Horizontal line.
Horizontal line going through which point?
-5.
-5.
-5 where?
In the -5, yes. They're in the y-axis.
Y-axis, okay. So right here. So this is that line. Perfectly flat, perfectly horizontal going through the point. -5 on the y-axis. Just remember all of these points, just like the other one. This point here is -9, -5. This point here is 3, -5. All of the points on this line have a -5 for the second coordinate, and there's no restriction on x, so that's why we only need to write y is equal to -5 in the equation. So two special cases we should remember: perfectly vertical, perfectly horizontal lines will look like this. All right. Next ones. If you have, I'm gonna just sort of keep going after we finish each one. If you do have questions at any point, please stop me and ask the questions. Otherwise, I'm just gonna try to keep getting through these as quickly as we can. Erase. Next ones. So, all right. Intercepts, the graph on the left, or here, I'll give you a moment. So find the intercepts based on the graph for the one on the left, and for the one on the right, try to find both intercepts, x and y intercepts. In class yesterday or today, I showed you a quick method to find those intercepts. if we are given standard form like this. So see if you remember those. Take a moment now.
So for question
wait, no,
35, should we find equation?
Wait, nope. Try it on your own. The instructions are here. Just find the intercepts. Please try, and we'll talk about them in a moment. All right, let's try these. The one on the left here first. So we're just being asked to find the intercepts, not being asked to find the equations. Or find, like, we could find the equation, but again, that's not what the question is asking. So what are the intercepts for the one on the left?
-5.
Okay, so we have, or sorry, let's give me a little more detail. Which intercept is which value?
5 is the x-intercept and -5 is the y-intercept.
All right, so x-intercept, we're just looking at the x-axis. Where does our line cross the x-axis? So x-intercept is 5, or if we want to write full details here, 5, 0. Y-intercept, same thing, except where it's crossing the y-axis. So this is -5 or 0, -5. All right. For the other one here, we have an equation in standard form. How can we figure out what the intercepts are? What's a quick, easy way to find them?
Let's move into the form that we know, like y equal mx plus b, right? We should find firstly find y, and then we're gonna find
all right,
intercepts.
So y equals mx plus b. That gives us b, which is the y-intercept, but it doesn't give us an x-intercept. So we could do it with this form, but as I showed you yesterday or today in class, there's a shorter, easier way to do it when we have standard form. Does anyone remember that method?
Yep, we can imagine that x or y disappears for a while. And for instance, if we imagine that y disappears, we can just find x and do that with the y.
All right, so just remember the intercepts, as we wrote here on the left. The intercepts are the points where the other value in the coordinate is 0. So we want to find the point where we have an x, but then y is 0. So for this one, just forget the y. So imagine the y isn't there, solve for x, 8 divided by 4, 2. We don't even need to write it out. It's just quick mental algebra. And for the other one, I have to erase there. For the y-intercept, we just forget the x because substituting in 0 just means it's going to disappear. 4 times 0 is 0. So here we have -y is equal to 8. So that means we get -8, 8 divided by -1. So those are the two intercepts here. If we again write these out in detail, 2, 0, and 0. -8, and then we could put those on a graph very easily. All right, so the slope-intercept form gives us the y-intercept very nicely, but it doesn't give us the x-intercept. We could figure it out just by doing this, substituting 0 in for the y, but it's not necessarily the easiest way of doing things. So this other method is very quick. All right, another example with that. Let's say we have this and right. So this equation in standard form, find the two intercepts and then draw the graph for this line based on those two intercepts. So I'll put the graph paper or graph grid up here. Take a moment, both intercepts plus try to make a graph representing this. All right, that's been 1 minute. Let's take a shot at these. So first, what are the x-intercepts? What is the x-intercept and what is the y-intercept here?
-10, -10, x-intercept.
Okay, x-intercept -10, y-intercept?
And 4. It is 4, positive.
+4, okay. Looks like everyone in the chat has that as well. So we have agreement here. So our x-intercept is -10. So there's -10. And the y-intercept is here, +4. And we just draw the line through the 2 points. That's it. Let's just want to make sure I get this lined up nicely. About through there. All right. Let's say we are not 100% confident. What could we do to try to check this line and make sure that we have it right?
Table of values.
We could do a table of values. I don't know if we need to do all those values. I think we could do it with just 1 point. Can someone suggest a way with just 1 point?
Like we can see point -5 and 2, and we can just add it to the.
Okay, so this point here.
If you,
So we can just choose, like we just heard, any point that we see on the line. So this looks like -5, 2 should work in our equation. So we can just substitute that in and see what happens. So we would get 2 times -5 and then -5 times +2 is equal to -20. What do we get? -10 minus 10, -20. So yes, it seems to work. So the line that we drew probably works out. We are relying on the graph, which is not like 100% certain here to assume this line here, but pretty certain that we have the right line here. We've used 2 points, verified with the 3rd point. Okay, So that's graphing. That's again how we find the intercepts very quickly. And then also how we can make a graph just using any two lines based on that. All right, that was the first section. We are at 8 o'clock, 30 minutes and 1, 2, 5. Okay, we're on a good pace here. So we'll do at least a few more. I think we will have time to do a quick break partway through. All right, next, slopes. So slopes of lines. Let's look at some special cases here, or sorry, a graph, and then a special case, and then we'll go to a more general version of this. Okay, so I'll give you a moment. Please think. These should be pretty quick. Let's take like, I don't know, 40 seconds. Just look, what's the slope on the left and the special case on the right? What's the slope there? And you can write them into the chat if you have them ready. Okay, let's try these out. For the graph, if I have a graph, can someone tell me how we will find the slope? What's our method?
Rise over run.
Okay, I don't know what a rise is. I don't know what a run is. Tell me more.
Rise is change in y, and run is change in x.
Okay, how do I find a change in y and change in x?
Find 2 points, and then just draw, I guess.
Okay, so choose any 2 points on the line. That's step number 1. Then we figure out what's the difference between the 2 y's, what's the difference between, what's the difference, yes, between the 2 y's, between the 2 x's, and we can get the slope from that. So tell me 2 points that look like they're easy to read off of our graph.
0,4 and 2,1.
Okay, so these 2 points right here. So we have 0, 4, and we have 2, -1. So we can use these 2 points, and our slope formula is equals delta y, change in y over change in x. So we can just, I'll write in the next bit in a moment, but just intuitively, look at the y value here and the y value here. How much did it change by? Let's say we kind of go in this direction. So 4, it went down by 5, so -5. So that is the change in y. And then similarly over here, for the x value, it went from 0 to +2. What's the change in x? Well, it's 2, it's +2. So delta y over delta x, so -5 over +2. The more formal way of writing this, y2 minus y1 over x2 minus x1. But we just take the 2 points and just think about the y values, think about the x values. How much did they change by? And then we can see what the slope would be. All right, so that's our slope, -5 over 2 or -2.5 if you want to write it that way. The one on the right here, what's this slope? I know some people wrote it into the chat, but I want you to actually say it so that we can all hear And also, so it's in the recording because the recording does not have the chat.
Well, there's no change in y, but there's infinite change in x.
Okay, so let's write, tell me 2 points that are on this line here.
1,3 and 2,3.
Okay, so 1, 3, and 2, 3. So both of these have a y value of 3, which is what this is saying. Y must also always be 3. So if we do our m here, our delta y over delta x, we will get 3 minus 3 on the top, on the bottom 2 minus 1, and 0 over 1, which is 0. Excuse me. 0 divided by any number will still be 0. So that's the slope. So for any flat horizontal line, our slope will be always 0. If we were to draw this on our graph, this is y equals 3. That would be this line here. That's a flat line. So again, another way of thinking about slope is when x goes up or down, let's say by 1, how much does y change by? Well, in this case, y doesn't change. It never goes up, it never goes down. So it doesn't matter how much you move with by x. So just 0. So slope for a horizontal line. Let's look at the next one. Next two. Oh. Yes, that's right. Okay. All right, next two. One more special case on the left and then a general case on the right. And we'll try to find the slopes for both of these. The one on the left, I'm going to do the same thing, picking two, like just any 2 random points and then actually trying to calculate it. So you can go through that process for yourself as well. So take a moment, try to tell me what these 2 slopes are. All right, the line on the left are first just basic description, special case. What does this line look like?
Vertical line.
Good. So this is a perfectly vertical line. So just, or that's not a very good vertical line. Let's try. So it's gonna look like this roughly. All right, tell me 2 points that are on this line.
-5,1, -5,2.
Okay, so -5, 1, -5, 2. And let's do our whole calculate the slope method here. M is delta y over delta x. Change in y, let's call this point 2, this point 1. So our change in y values going from 2 to 1 is 2 minus 1. That's our difference. And then for the other one, we have -5. Change in x is no change, but let's just write it out formally here. 1 over, and we will get a 0 on the bottom. What's happening here? If we see division of 0, what do we call this?
Undefined.
Right, so this is undefined because it's not defined. Ask the best math person in the world, and they also cannot tell you, if you take a thing and divide it into 0 parts, how many parts do you have? No, math people have not been able to agree on that, and they won't. So this is an undefined slope. We can't write any number for it. So we can't have a number for the slope, but we do remember that this special case just gives us a perfectly vertical line, because these 2 points would be just right on top of each other, like this, for example. Okay, on the right side, what is the slope that we have?
-1.
-1. Okay, I see a few people wrote -1. So let's just double check that. Delta y, delta x, y2, y1, x2, x1. That's the formula. Put in the numbers that we have here. Let's call this point 1, call this one point 2. So we have -2 minus -5 over, and on the bottom here we have 1 minus 4. All right, and so on the top we will get 3, +3, and on the bottom we get -3. That's just -1. So that's the slope. All right. So that's those 2 questions. Next will be a bunch of questions about or 2 questions about graphing based on or using slope to actually graph a line. Does anyone have questions at this point about just the algebra part of this and calculating a slope and sort of the concepts of what a slope is before we try to do the graphing stuff?
Yes, I have a question. May I ask?
Sure.
About question 83, x equals to -5. You said it's a vertical line. How do you know this? How to define this?
Right. So let's jump back to, where is that one? Here. So when we did this one, so just -5, -2 doesn't matter. Just it's easier to show you with the graph here. So this is saying x must be -2. The x coordinate must be -2. So if we were to try to just make up a bunch of points, or actually let's do this with the table of values. So -2 here. So table of values. So let's try to write out some values here. Let's say -4, -2, 0, and 1, and 3 for y. So we can do table of values in both directions, choose a random number for x and calculate what y would be, or we can choose a random number for y and calculate what x would be. So when y is 0, what is x? When y is 0, what must the x value be? For this equation here.
-2.
-2. Why? Because x is -2. X must always be -2. It cannot be anything else. It's not depending on anything else. X is always -2. When y is equal to 1, what is the x value?
-2.
-2, -2, -2. So there are no conditions, no restrictions on y, but on the other side, we have an extreme restriction on x x must be -2. There are no other options. So we can just draw all of these points, -2, 0, let me thicker pen here. -2, 0, -2, -2, -2, -4, -2, 1, -2, 3. Look at all the points. What's that shape? It is a vertical line going through -2. So that's how we know it's a vertical line. Just table of values. Just make a bunch of points. What is the shape that those points make? So if we say just slope is undefined, well, what's the slope? Like, or what does it actually visually look like? If we just think about it like that, it's kind of confusing, but consider the table of values, and then we see that there's no other possibility. It must be a vertical line. So that's how we know, because we graphed it before and we remembered what the shape is, and we remember that x equals something must be vertical. So hard to see from the slope value itself, but very easy to see from the table of values. Does anyone else have questions about slope stuff before we do the graphing ones?
No.
No, we're good. All right, let's go back. We did that. We can hear. Okay. We had 1, 2 graphing, and then relationships. Okay. All right. So we have two different situations here. We have a point and a slope. And then on the right, we have a full equation, but not in slope intercept form, in the standard form here. So we want to graph both of these. So for the one on the, okay, I won't say anything. I'll let you guys think about it and see how you would graph these. We have a few different options. Again, try to use the easiest method, whatever is most straightforward for you. So take 2 minutes here. Try to graph both of these situations, both of these relationships. So put the graph paper up here. Okay, that's been 2 minutes. Let's see what we can do. For the first one, number 99, what do you think is the easiest strategy to graph this?
Just start from point negative 4, 2, and then
negative 4, 2.
Just draw another point using the slope 4, rise by 4, run by 1.
Okay, so we could take the slope and the point and figure out the slope intercept form and then find the y-intercept and then start at the y-intercept. Or we can just start at the point. That also works. Slope and point is enough to define a line. So we're starting here. And so remember slope, if the slope is m equals 4, that's the same as 4 over 1. And remember, slope is delta y over delta x. So if the x value goes up by 1, and the y value is going up by 4. 1, 2, 3, 4. There is the next point on the line. Also, this works in the other direction. When x goes down by 1, negative 1, then y must go down by 1, 2, 3, 4 here. And there's another point. So that gives us 3 points. That should be more than enough to confidently draw this line. I will do that now. Starting here. Okay, so there's our slope. We use the slope to just find the next point, and maybe find like the next 2 points if we want to be certain. And we can just start from that whatever point we were given. We don't need to go to the equation. We don't need to build the equation for the line. We could, but if we're not being asked to, then it's not necessary. All right, for the second one, for the 115, how could we graph that line?
Maybe convert the equation first to slope intercept form.
All right, we want to do slope intercept form. So let me move this over here. All right, slope intercept form. How can we convert it?
Divide all of them by 2.
Okay, so 3 over 2x minus y equals 2.
And then rearrange it so that subject.
Okay, so we want the y to be isolated. We want the y to be separate. So 3 over 2x minus 2 equals y. And then usually we look at it in the other direction. So y equals 3 over 2x minus 2. Okay, we've converted. We now have slope intercept form. Now what can we do?
First, put the y-intercept on the graph, which is 0, negative 2.
Okay, so here's our y-intercepts.
And then points, just use the slope again.
Right, so slope, again, the delta y over delta x, the rise over run. So rise as y-intercept, run right left as x-intercept. So bottom number is at 2. That's saying when x changes by 2, goes up by 2, then the y value must go up by 3. And that gives us a second point here. And we can do the same thing. When x goes up by 2 again, then y should go up by 3 again. Gives us the next point. Or going down, when x goes down by 2, left by 2, y should go down by 3 like this. Here and here. That's lots of points. And we should be able to just draw through like this. they all line up. They all look very clean. They touch our line very nicely. So looks like we did things correctly. So standard form, we could always change into slope intercept form, and then slope intercept form is slope and the y-intercept. Those are pretty easy to use. There's the intercept, and then slopes just count off and find the next points. Okay, so that's the graphing approach here. There are some kind of just shortcuts. So things we can sort of notice about patterns of slopes and just looking at a number, roughly what it will look like without having to count it off. I haven't really talked about that. We'll next week, I guess. That's a very useful part of graphing and becomes essential when we do calculus stuff later in the semester. So we'll do a little bit of that in our next class likely. But for now, you can always just count off change in X, change in Y, and you'll be able to figure out what the slopes are. Okay. Next 3 questions are about related lines. So we had similar questions in class, or similar concepts. So relationships between the 2 lines. First, let's say, what are the possible relationships between 2 lines?
They could be parallel, perpendicular, coincident.
Parallel, perpendicular, coincidence, or
and intersecting.
Right, just intersecting, like, so nothing really special happening between them. Parallel means what exactly? What do we say about intersecting with their parallel?
Same slope.
Okay, so let's write this out here.
They don't have similar points.
Right, so no intersection. So that's the property. That's what parallel means. And how do we identify that? We figure that out when they have the same slope, and different intercepts. So same slope and different intercepts means that we have parallel lines. Perpendicular lines, what is the general property? What does perpendicular mean?
There is an intersection which creates a 90-degree angle.
Right,
Right angle.
90. I don't have an easy key to press the degree button. 90, I'll just type it out. 90 degrees. Or yes, that is a right angle. All right, and we know that. How do we figure out if 2 lines are perpendicular? Using slope.
One slope is the negative reciprocal of the other.
Okay, negative reciprocal. That's a very fancy word. Tell me that in a different way.
Negative.
Yeah, that's good. It's good to know the word, but we also want to be able to talk about it in just plain language too, because that's easier to think about.
M1 equals to negative M2.
Okay, so M1, whatever slope number 1 is of 2 lines, I'll write it this way. If we multiply it by the other slope that we have, the result will be -1. I'll show it a little more cleanly in a moment, but when it's hard to type fractions here. All right, last one, coincidence. What does this mean?
Equation looks different, but they're actually the same, so they overlap each other.
Okay, so when we graph the two lines, they're fully overlapping. Every point that's on one line is also on the other line. How do we identify that? What do we look at in the equations? What thing will tell us if they are coincident or not?
I don't know how to say it in English.
So for parallel, same slope, different intercept. What's going to be true about coincident lines? Is the slope the same or different?
It is the same, but in the equation could it could be a different number, but if you simplify it, it's the same.
Okay, so that means it is the same slope. The slope is the relationship. It's a ratio of how much do we go up by compared to how much do we go over by. It doesn't matter if the one number is bigger, like 2/1 is equal to 4/2 is equal to 6/3. Those are the same thing. We don't say that those are different numbers. Like those are equal to each other. So if these were slopes, all of these are the same slope. So just like mathematically, they are equal. All right, so same slope for coincident lines. And what else will also be true?
Same intercept.
There we go. Same intercept, same y-intercept. If it's not the same intercept, then that means that they're just parallel. They won't be touching each other. Okay. And for the intersecting situation here, it's just different slope. Doesn't matter about the intercepts, but if the slopes are different, then we'll have an intersection of the two lines. So there's our little summary here down here at the bottom of what we're looking for. So I will give you a moment here. We have 3 different pairs of lines. Do some rearranging, do some figuring out. Tell me what the relationships are in each pair. Is it just regular boring intersecting? Is it special perpendicular intersecting? Is it parallel, or is it coincidence? Got 4 different choices. So we'll spend a bit more time on this, 2 minutes, 3 minutes maybe. When you have your answers, type them into the chat. Try to figure out the relationships. So go ahead. All right, that's been 4 minutes. So let's try these out. So number one, the one on the left, 135. What do we think the relationship is between these two lines? Tell me your guess, and then we'll go through and check it.
Coincident.
Okay, I heard parallel and I heard coincident. So remember, a coincident is like a special kind of parallel. So, okay, so let's check. Is it like just parallel, or is it parallel but also coincident? I didn't tell you this yet, but how can we check these? Or tell me what your strategy is to figure out what the relationships are.
For the first one, just simplify the first.
Okay, so just simplify the top one. Okay, sorry, Zoom just, you guys can still hear me? Still see me?
Yes.
Yeah, okay.
Everything's good.
All right, so before, if we do any, we might think, okay, let's rearrange to slope intercept form, but we can see, well, okay, we have a common factor of 2 here that we can take out. So if we do that, then we divide both sides by 2, x minus 2, y equals 3. And then what do we notice?
It's the same with the second equation.
Right, the two equations now, so we see that they are actually the same thing. They kind of looked a little different. Some of the numbers were different, but they actually, it's the exact same relationship between x and y. So what does that tell us? Which of these situations should it be, or is it?
Coincident.
Okay, so if we say the person who said it's parallel, tell me why you think it's parallel and not coincident.
Yeah, when I divided the both parts, I just forgot to divide the 6. That's why I got this parallel.
Okay, so that's our parallel answer. So it's the exact same here, so both parts will be the same. So even if we have not yet changed it into slope intercept form, if they're both the same equation, then when we change them, they will be the same slope intercept form. So it must have the same slope and the same intercept. Let's just do that here for thoroughness. So x equals 2y plus 3. So x plus 3 equals 2y. And we'll divide both sides by 2 here. 1 over 2x plus 3 over 2y. Flip this around, 1 over 2x plus 3 over 2. A few extra steps there. So that's the slope, it's 1 over 2. That's the y-intercept, it's 3 over 2. But we could answer this problem without even needing to check that. We know that they are coincident because they have the same equation. So coincident. That's our answer there. For the second one, tell me what you think the relationship is, and then we'll see how we can check it.
Perpendicular.
Say perpendicular. Excuse me. So perpendicular. So perpendicular, maybe. Let's check. What's our strategy? What's our method to check this?
Convert them into slope intercept form first.
Okay, so I'm going to label these equation 1, equation 2. So equation 1, we want this in slope intercept form. So just some algebra rearranging here. 7x minus 4y equals 8. So a little faster than what I did on the other side. We're going to get 7x minus 8 is equal to 4y. So 4y, 7x minus 8. So y is 7 over 4. X minus 2. All right, there is equation 1. And we can do the same thing. So, or we can note here, that's our slope, and that is our y-intercept. Let's do the same thing with the other one, number 2. So equation 2 for x plus 7y equals 14, and rearrange 7y equals 4x minus 14. Y is equal to, I missed one thing here. That should be negative 4x. Negative. Okay. So negative 4 over 7x minus 14. So divided by 7. So minus 2. All right. What do we notice here about these two now when we compare them?
It has the same intercept.
Okay, same
slope.
intercepts. That's interesting. And what about slopes?
So negative 4 over 7 is the negative reciprocal of 7 over 4.
Okay, so the negative reciprocal, I'll explain that here. So slope 1 here is 7 over 4. Slope 2 on the right is negative 4 over 7. We can see that these fractions are similar. We flip over the fraction, or if we took the first one, 7 over 4, we flip it over to make it 4 over 7. And then we flip the sign on it as well, in this case from positive to negative. That's the negative reciprocal. And then that is the thing that tells us that the two lines are perpendicular. That's the special relationship. So if we multiplied them, as I mentioned down here, m1 times m2, if that's equal to -1, so 7 over 4 times -4 over 7. So -28 over 28, that's -1. Okay, when we multiply the two slopes together, we do get -1. So yes, they are perpendicular. This is the thing I've not properly explained this here, like exact why is it -1? Like, so there's a little kind of proof here that would really convince you of this concept, but I'm not going to do that here for sake of time. Just you can remember, if we want to know if two lines are perpendicular, look for the negative reciprocal. So flip over the fraction and reverse the sign. Just that special relationship means that they are perpendicular. So we were right up here. That's, yes, these two lines are perpendicular. Perpendicular.
Professor.
Yep.
Is it perpendicular and intersecting?
Yeah, so perpendicular means intersecting. So it means that they intersect, and when they intersect, we have a special case of that they intersect at a 90-degree angle. So perpendicular is a special case of intersecting, and coincident is a special case of parallel. Like, we sort of talk about them as separate categories, but you know, there's like the actual concept, so we can understand that it is a special kind of sub case. All right, last one here. So let's switch colors. What have I not used yet? Brown. All right. So two equations. These look kind of similar. These like there's a lot of sort of shared bits, shared parts here. So maybe we'll have a special relationship between these two. What is your guess? What do you, or tell me what you think the relationship is between them?
Probably intersecting.
Okay, so we think it's just a boring, nothing special, just intersecting lines. All right, so if we're going to check this, again, we can just convert to our slope intercept form. I'll label these 1 and 2. Equation 1, 3x minus 2y equals 1. So 2y is equal to 3x minus 1. Let's just make sure, yep, did that correctly. So y is equal to 3 over 2x minus 1 over 2. That's the first one. Second one here is 2x minus 3y equals 2. So 3y equals 2x minus 2. Y is equal to 2 over 3x minus 2 over 3. All right, we have different intercepts. So here, -1 over 2, -2 over 3, different intercepts. So nothing special happening there. If we look at the slopes, we have 3 over 2 and 2 over 3. They are reciprocals, but they're not negative reciprocals. They have the same sign. So in our math terms, there's nothing special about this. It sort of looks like it's kind of flipped over one of the axes. It is not special to us. We don't really care about that. That's not a special property, or it's not a useful, really meaningful property in math. So they are flipped over, but not negative, not flipped over and then negative. So this is just the boring regular intersection case, and nothing special is happening here. So those are our 3 answers. The one on the left, coincidence. The one in the middle, perpendicular. One on the right, just regular intersections. All right, so we have 5 more I have planned here. Find the equation from the graph, not too bad. Find the equation, that's easy. Equation, easy. Those aren't gonna be too bad either. All right, let's just take a little breather. We've gone through more than half at this point, but before we do the other sort of full-on equations of line stuff, what time are we at here? We have 8:53. Let's take a break and come back at 9 o'clock, and then we'll go through the last few questions. So short break here, take some time. During your break, don't look at another screen. Don't read your Instagram feed or whatever. Like, just stand up and walk around or talk to someone. Don't read things. Don't do computer stuff. You need a different kind of brain activity for it to actually be a useful break for yourself. All right, see you in about 6 minutes. Okay, it is 9 o'clock. 9:01. I was on time. All right. Last bit here for us to go through. about actually dealing with equations. Here we are. So first one, let's look at a graph, see if we can find the equation from that graph. All right, sorry, I'll give you a moment to think. This first one shouldn't be too bad. So take 30 seconds, try to figure out what the equation is from this. We can do slope intercept or we could do standard form. All right, let's try this out. Excuse me. So what do we do? How do we figure this out?
Well, you can already see the y-intercept. So we got that.
Yeah. We got the y-intercepts right there for us. So y-intercepts is 0, +3. So when we write this in our equation, the b value will just be 3. So in case we forgot, y equals mx plus b is what we're looking for. So we already have y equals mx plus 3. So we need slope. How are we going to figure out slope?
Just count manually from the graph from 2 points.
Tell me 2 points.
0,3 and 3,-1.
Okay, so and there's even like a point very clearly labeled on this for us. So we'll take these 2 points, 1 and 2. Any 2 points on this will work to give us the slope because it's the same slope everywhere. It's the same difference, the same ratio. So it doesn't matter what 2 points we take. So this is 0, 3, this is 3, -1. All right, so our slope formula, delta y over delta x, y2, y1, x2, x1. And we just choose one at random to be 0.1 and 0.2. Let's call that 1 and call that one 2. So the y values, what's the difference in y when we go from this one over to this one? Well, it's -1 and -3 here. And the other one, we will have our difference in the x values from 3 to 0. So 3 minus 0. Like this, and that is -4 over 3. Someone asked me this in class today or after class today, so I'll just show you the other direction. It doesn't matter what order we do the subtraction with the points in, so let's just do the other one as well. So let's switch these around, make 0.1, 0.2, and make 0.2, 0.1. So if we do that, then we would have 3 minus -1 on the top here. So that looks like it's going to be different. Looks like we're going to get a +4. So maybe we think that's a problem. And on the bottom, we're going to get a different thing too, -3. But +4 over -3, That's the same thing as -4 over +3. Those are mathematically the same. So that's the only difference we're going to get if we do the subtraction with the points in the opposite order. It's the same thing. We're going to get the same slope. So there's our equation, y equals -4 over 3x plus 3. That's the equation. So slope, choose any 2 points. And in this case, we can even see the y-intercept. So not very hard to pick that one out. That's how we find the equation. All right, I was kind of writing quickly here. I'll just give people a moment in case they need it. All right, next 2. So we have a slope and a point on the left. We have 2 points on the right. So no graph this time. Let's just use algebra. Find the full equations slope-intercept form for both of these lines. So I'll give you a bit of time to work. If you have them, write the answers into the chat, please. All right, that's been 2 minutes. So let's give these a shot here. On the left, okay, once again, I'll write this out. Y equals mx plus b. This is what we're trying to build. We have m. So m is -7. That's pretty useful. So -7x plus b. We can already go to this point. How do we figure out the last part here? We have a point, but we need a y-intercept.
Just substitute both coordinates into the equation.
Right. So again, this is x, y, that pair. So this is an x value. This is a y value. Substitute these values in here. So -3 equals -7 times -1 plus b, and that's -3. 7 plus b is equal to -10. So y is equal to slope here -7x minus 10. Okay, so we have a slope and any coordinate, any point, if it is on the line, and we were told it was here, then it will work. It will satisfy the equation, and we can use that to figure out other parts of the equation that we don't know. On the right here, how can we figure out this one? We have just 2 points.
Well, 0,4 is basically the y.
Okay, so even like a little handy shortcut here, normally we would like find slope and then we would find the y-intercept afterward, but we can just notice, hey, that's b. B is equal to 4 because that's the y-intercept. We still need slope though. How can we do that?
y2 minus y1 over minus x1.
All right, the exact same formula, delta y over delta x. So let's just call these points 1, point 2, -3 minus 4 over 2 minus 0, -7 over 2. So y is equal to -7 over 2, x plus 4. If we didn't know the 4, if we didn't recognize that from the point here, then that's okay. We could just have this. So y is equal to -7 over 2x plus b, and then substitute in either of the 2 points that were given and calculate what b is, and it would turn out to be 4. So I'll leave that to you guys to work out if you're curious. But often there are shortcuts. There are things we can notice if we're just sort of aware and not just kind of like blindly following some formula or some method. Just kind of keep your I don't know, math observation, math critical thinking, math sort of creativity part of your brain engaged, and then we can notice little things that will make our lives at least a little bit easier when doing these problems. All right, that's those two. It's pretty standard way to figure out equations given some information. And 2 more here, the last 2 of the evening. So if we are given this line and this point, find the equation of a line that is parallel to the original, this given line and going through this point. And then on the right, find the equation of a line that is perpendicular to this line going through this point here. So last 2, I'm not going to tell you how to find the perpendicular and parallel slopes. We did that already. I hope you remember. So take a bit of time here and try to figure these 2 out. a few more seconds here. If you have the answers, you can write them into the chat. All right, let's try these out. On the left here. Parallel lines. So we have this original equation. We want a parallel line going through this point. What's the first thing we're going to do?
The slope should be the same.
Okay, so we have to remember that parallel lines have the same slopes. The slope in the original one is 4. So M is 4. So we have our target line, the one we're trying to make here, is going to be y equals 4x plus b, some point b, and it's going through the point 1, 2. Now what?
Substitute.
Substitute. Same thing we just did on the previous 2 questions. So 2 equals 4 times 1 plus b, and we'll just skip straight to this here. So our b is going to be 2 minus 4 and negative 2. All right, and all right, sorry, let me actually write this out here. Y equals 4x minus 2. Let's take a look at the 2 on the right here. Sorry, the 1 on the right. What are we gonna, we have a little more work we might have to do in advance here. What's the first thing you want to do with this problem?
Convert the equation to slope-intercept form.
Okay, slope-intercept form. We know relationships of, if 2 lines are perpendicular, we go from this slope to that slope. So let's convert this. So if we do that, we will get 5y equals negative 2x plus 6y equals negative 2 over 5x plus 6 over 5. All right. And what is the, what's the next thing?
Find the slope of the perpendicular line.
Okay, how do we do that?
Negative reciprocal of negative 2 over 5.
Okay, so we've talked about negative reciprocal already. Sorry, I didn't actually write that out, so let me just type that quickly here. Negative reciprocal, in case you want to see the spelling. Reciprocal, yep. Drawing tool. So our original slope, we can see here with our slope-intercept form, is negative 2 over 5. So the negative reciprocal of this, flip over the fraction, reverse the sign. That is 5 over 2 and positive because the original one was negative. So we have y equals positive 5 over 2 x plus b. What can we do to finish this?
The y at the origin. So
what does that do for us?
don't write the b.
Yeah, there's no b. So
yeah,
if it's 0, 0, it's still, oh, sorry, not that one. The x value is 0, so it's still a y-intercept. It's just b is 0. So it's going exactly through the origin here. So we just forget the b. So y equals 5 over 2. I'll just write this very thoroughly, plus 0. So just y equals 5 over 2x. Anytime you have an equation of a line that has no constant, so it can have coefficients on the x and or the y, but no constant means that it goes through the origin. If we were to convert this to standard form, just for fun here, I guess, if we do that, we would get 5 over 2x minus y equals 0. And then we don't like fractions with these, with standard form here. So we would get 5. No, I'm going to move this. Don't want to be too cramped down here. A little bit up. All right. So then that gives us 5x minus, we multiply everything by 2, 5x minus 2y equals 0 times 2 is still 0. So it would look like this. So converting to slope intercept form will let us see the slope. Something I didn't mention in class, but we could see here. Let's do this with the one on the right. So let's get rid of this. The standard form, what's just the generic form of a standard form of a line? Slope intercept form is y equals mx plus b. What is the generic form for standard form?
Ax minus by equals to c.
By equals c. If we don't know if the b is positive or negative, then we don't need to write negative. So we usually write it like this: ax plus by equals c. If the b is negative, then it will become a negative when we put in actual numbers here. So given this a and this b here, look at the relationship that we see with this standard form and then this slope intercept form. Tell me what slope is in terms of the a value and the b value here. So if I look at a standard form of a line, how can I just immediately see the slope without moving things around in terms of a and b of standard form?
Well, the slope should be the coefficient of x.
Just that is a
over b.
Okay, a over b. So what we had here was 2 and 5. So that would give us a slope of 2 over 5. But we figured it out to be negative 2 over 5. So we're pretty close. What do we need to add here?
Negative fraction.
Right, negative a over b. It's not really the a that's negative in particular. So I'll just write it this way: negative a over b. So if we have standard form, then this is what the slope will be. In slope intercept form, the slope's just given. It's m, it's right there. But if we have standard form, then we can just very quickly look and see what the slope will be. So if we compare those, then if we look at this other one here, the answer to this question, what's the slope? Here, again, just reading it, we have a, which is 5. We have b, which is negative 2. And then that whole thing, negative. So that's 5 over 2. And that's what we found here, 5 over 2. So we don't always have to convert to to slope intercept form to see the slope. If we remember the negative a over b, we can just see the slope there as well. And as we did with the earlier questions about finding the two intercepts from standard form, so we can see the slope directly, we can see the intercepts directly. So if we're familiar with that, we don't actually have to, we don't need to convert it to slope intercept form. We can get everything that we need for graphing just directly from standard form. We can just see it in the equation. Okay, all right, that was long. That was just about 9:30 marathon workshop here. We went through lots of questions and 30 people, well, one of those is me, so 29 people still here, so lots of you stayed around. Does anyone have questions, general questions that they want to ask about what we just did?
No questions.
No? Okay. If you do have more questions you want to ask, or you want to go through, look at one of the examples again, you want some more explanation, whatever, then just hang around. I will talk some more with you, but everyone else, we are finished. Thank you for attending. I will see you in class or whenever the next thing is. Goodbye.
Sorry, Professor.
Goodbye. Thank you.
Thank you, Professor.
Wow.
Thanks, Professor.
Sorry, Professor. Can I ask a question about not the topic?